Welcome to the debate. So for at least a decade, the data scientist was basically the undisputed wizard of the tech world.
Oh, absolutely. The person behind the curtain.
Right. You were the person who could, look at just a mountain of raw numbers, build some wildly complex mathematical algorithm, and essentially predict the future.
But today, there's this staggering statistic. 64% of senior data leaders say a technology built primarily to, write text and generate images might actually be the most transformative tool they have ever seen.
Yeah, it's a massive shift in industry sentiment. And to be clear, we are talking about generative AI here. So models like ChatGPT or Claude, stepping out of the creative department and into what has historically been a rigorous, highly quantitative world of data analysis. Which brings us directly to the core of our discussion today. Will generative AI completely replace predictive machine learning? And specifically, what does this mean for the people actually in the trenches, the data analysts and the data scientists?
Right, the folks actually doing the work.
Exactly. And I'll be taking the stance that, yes, it will. I look at how rapidly these new tools capture incredibly complex correlations, combined with how they completely democratize data analysis. To me, it is very clear that generative AI will ultimately subsume traditional predictive machine learning entirely.
And I will be arguing the opposite. I look at that exact same landscape and I see a hard mathematical limit. Predictive machine learning remains structurally irreplaceable for scale and accuracy. Generative AI is, it's inherently designed for content creation.
Which it's great at.
It is brilliant at it, but it is not built for the rigorous, high-volume statistical analysis of structured data that true enterprise data science requires.
Okay, well, let's actually look at the daily reality of a data scientist to see why that shift is, why it's happening right now. For years, the traditional workflow was incredibly manual and just painfully slow.
Yeah, painful is the word.
If a company wanted to predict customer churn, for example, or classify product defects based on customer feedback, building a custom machine learning model took massive effort. You had to gather the data, clean it, manually label thousands of examples, and then spend weeks on hyperparameter tuning.
Just to level set for a moment for those listening, when you say hyperparameter tuning, you're talking about the meticulous, really manual tweaking of the math?
Right.
Like adjusting the learning rate or the depth of the decision trees, just to get the model to recognize a pattern accurately without, memorizing the training data.
Exactly. It was a highly specialized, highly expensive process. But today, we are seeing generative tools being used entirely off the shelf to instantly bypass that entire pipeline.
Instantly is a strong word, but go on.
Well, practically instantly. If you want to find product defects in thousands of online customer reviews today, you don't build a custom natural language processing model from scratch. You just hand that text to an off-the-shelf large language model, an LLM, and ask it to classify the defects. It does it immediately, and often with higher accuracy than a model you spent 3 months building.
For text, sure.
But it goes beyond text. MIT Sloan Associate Professor Swati Gupta explicitly notes this transition. She points out that while traditional machine learning captures complex correlations, generative AI goes further. Because it is, pre-trained on the entire internet, it possesses a sort of worldly context. Fine-tuned generative models are now identifying relationships within traditional data sets that standard machine learning simply can't see.
Look, I understand the appeal of an off-the-shelf solution, especially for text analysis, but we really have to separate ease of use from analytical rigor. You mentioned analyzing customer reviews. That is unstructured data. It's language. That is exactly what an LLM is built for.
Right, but
the day-to-day reality for a huge portion of data scientists is vastly different from reading reviews. They are dealing with continuous numerical data. MIT Sloan professor Rama Ramakrishnan makes a really brilliant distinction here. He says, and I quote, "It's a lot easier to collect data than to collect understanding."
How so, in this context?
Think about the underlying architecture. If you want to teach a program to accurately predict a subtle pattern in, say, credit card transactions, feeding it thousands of rows of numerical data is a completely different mathematical task than using an LLM to summarize a document.
Sure, the inputs are different.
The whole mechanism is different. Generative AI creates. It is literally a predictive text engine that guesses the next most likely word or token based on semantic patterns. Predictive machine learning makes decisions based on calculated statistical variance. They just aren't interchangeable.
But I think that assumes the barrier between language and math hasn't already been broken by these models. Look at the democratization happening in the field right now.
Democratization is happening, yes.
It's exploding. We have tools like Jupyter AI, Data Robot, H2O.ai. We have massive business intelligence platforms integrating AI directly, like Tableau AI and Power BI with Copilot. A business analyst, someone who doesn't know Python or how to structure a regression algorithm, can now literally prompt a data set in plain English and receive a complex, accurate classification.
They can.
The LLM basically acts as an intelligent translation layer between human intent and the underlying data. It completely removes the technical barrier to entry that kept predictive ML locked inside these specialized engineering teams.
It is a wonderful advancement in user interface design. I will totally give you that. But a data scientist cannot rely on an LLM as a core analytical engine for mission-critical decisions. Let's use an analogy to explain the difference in the actual mechanism here.
Okay, let's hear it.
Traditional predictive machine learning is like a master sommelier who has been trained exclusively to detect the exact chemical balance of a specific wine. They measure the acidity, the tannins, the sugar content with absolute mathematical precision.
Okay, and generative AI is what?
Generative AI is like a really well-read author who has read every single book ever written about vineyards.
Oh, I see where you're going with this.
Right? The author can describe the history of the region beautifully. They can synthesize tasting notes based on what others have said. But if you hand them a mystery glass of wine, they might completely hallucinate the actual chemical makeup because they are predicting words that sound plausible, not actively measuring the chemistry.
I mean, that's a clever analogy.
And Swati Gupta, who you mentioned earlier, specifically cautions that companies using generative AI must be acutely aware of potential inaccuracies. When you are dealing with banking fraud, you cannot afford a hallucination. The black box nature of a generative model, where you literally cannot trace the mathematical weight of why it flagged a transaction, is just unacceptable for real risk assessment. A specialized predictive model is mathematically constrained. It doesn't guess what sounds right. It calculates what is mathematically optimal.
That is a fun analogy, but I really think it drastically underestimates how generative AI is actually being deployed in modern database environments right now. You are assuming the LLM is just blindly guessing the chemistry.
Well, it's predicting tokens.
Let's look at how AI database management tools like Ivan AI, Supabase, Text-to-SQL technologies, how they actually function. They aren't forcing the language model to natively crunch 10 million rows of numerical data.
So what is it doing if not analyzing the data?
It is writing the code that analyzes the data. Right? These tools allow developers to interact with incredibly complex structured databases using plain English. If an analyst asks, identify the transaction anomalies in Q3, the LLM translates that intent into a highly optimized SQL query or a Python script in seconds. It bridges the gap perfectly.
But the database is still doing the math.
The traditional engine still executes the math, yes, but the generative AI orchestrates the entire process. It understands the schema, the relationships between the tables, and the metadata far better than a rigid ML model ever could. That is exactly why Professor Ramakrishnan actively advises businesses that if a problem uses everyday information, analysts should try generative AI first. He explicitly says, don't reflexively go back to machine learning like you used to.
Yeah, but that phrase, if a problem uses everyday information, is doing a lot of heavy lifting there.
Is it?
Oh, absolutely. And it brings us to a major technical roadblock that I think you are kind of glossing over. It's the actual nature of the data itself. You mentioned the LLM orchestrating the query, but what happens when the model itself has to actually ingest and evaluate the raw numbers? Have you ever looked closely at how an LLM processes numerical values?
You mean tokenization?
Exactly. Tokenization, this is a crucial concept. When you pass a spreadsheet with millions of numerical rows into an LLM,
It doesn't natively understand those numbers as continuous variables on a mathematical scale. It chunks those digits into text tokens.
Right, it breaks them down.
Yeah, take the number 45,000. The LLM might break that into the token 45 and the token comma 1,000. It processes them based on how often those specific character sequences appear together in its training data, which, remember, consists mostly of human language. It is quite literally using grammar to try and do math.
Which is exactly why the industry is rapidly developing fine-tuned models, specifically trained on quantitative data sets. They're fixing that.
But the underlying architecture, the transformer model, is still predicting tokens. Compare that to a traditional predictive model, like a random forest or a gradient-boosted tree. When a predictive model sees the number 45,000, it treats it as a precise coordinate in mathematical space. It calculates the variance, it draws a regression line.
Okay, I agree the math is different under the hood.
Traditional machine learning is explicitly and mathematically designed for these high-volume quantitative environments. When we talk about continuous sensor logs from manufacturing equipment or the sheer velocity of financial markets, the predictive model is calculating actual statistical distributions. The generative model is just playing an incredibly sophisticated game of word association with numbers.
Look, I completely understand the distinction and how the math is processed. I do. But let's look at the economics, right? The realities of deployment. Because that is where predictive machine learning is losing its grip on the industry. Think about data drift.
Okay, data drift. When the real-world data changes over time and the original model starts to degrade.
Precisely. If you build a rigid predictive ML model to categorize customer behavior, and suddenly a new trend emerges, say a massive global event completely shifts buying habits overnight, your custom model breaks. It literally doesn't know what to do with the new variables.
You just have to update it.
But updating it means you have to pull your data engineers off other projects, relabel the new data, retrain the model from scratch and deploy it all over again. It is incredibly brittle and wildly expensive.
It requires maintenance, yes, like any complex system.
But contrast that with an off-the-shelf generative model like GPT-4 or Claude. Because of their massive generalized training, they adapt to new contexts dynamically. You simply update the prompt. You don't need to spin up specialized cloud infrastructure to retrain a bespoke algorithm.
So it's cheaper.
It's way cheaper. You achieve equal or better accuracy in classifying those shifting user behaviors in minutes rather than months. Why would a company ever approve the budget for an entire custom ML pipeline when a data analyst can solve the problem instantly with a simple API call? Generative tools eliminate massive overhead. Over time, fewer and fewer companies will be priced out of advanced data analysis because the generative approach is just overwhelmingly more efficient.
It is an economic miracle for specific domains. I will not argue that at all. If you are analyzing text, sentiment, or basic categorization, the API call wins every time. But when we look at true enterprise-scale operations, the unit economics of generative AI completely fall apart, along with its technical capabilities.
Fall apart? How?
Let's talk about the realities of scale, speed, and computing on the edge.
The edge meaning like running models locally on devices rather than in a massive cloud data center?
Yes, exactly. Think about the AI tools designed for cybersecurity, like CrowdStrike, Darktrace, SentinelOne, or DevOps monitoring tools like Dynatrace. What are those tools actually doing in reality? They're sitting on individual servers, analyzing millions of network events per millisecond to detect unusual activity in real time.
Right.
They have to respond to a zero-day ransomware threat automatically in microseconds before the damage is done.
And they use predictive ML to do that.
Exactly. Because a predictive machine learning model, like a highly optimized decision tree, can be stripped down to a few megabytes. It is incredibly lightweight. It requires almost zero compute power to execute a split-second mathematical filter. Now imagine trying to do that with a generative AI architecture.
Well, you wouldn't use it for that exact.
You physically cannot pipe millions of network packets per second through a massive transformer model via an API. The latency alone makes it impossible. And even if you ran it locally on the server, the compute costs, the sheer amount of electricity and processing power required
to generate millions of tokens continuously, it would bankrupt the company. Generative AI is a heavy, computationally expensive architecture. It simply cannot perform this kind of real-time, high-stakes predictive processing at the edge.
I see why you emphasize latency and real-time processing. Those hardware constraints are very real. But I would argue you are isolating extreme edge cases to defend the entire discipline of traditional ML. Yes, cybersecurity event monitoring at the millisecond level requires lightweight models. But let's step back and look at the vast majority of data analysis happening in businesses today.
Okay.
Market forecasting, supply chain optimization, customer churn prediction. That analysis doesn't happen at the millisecond level. It happens at the human level.
Meaning what exactly? Human level.
Meaning the output ultimately has to be synthesized for a human decision maker. And at that human level, the ability of generative AI to not just identify a pattern, but to actually explain that pattern is fundamentally more valuable than a simple statistical output.
Okay, explain.
Well, if a data scientist uses traditional ML to analyze customer churn, the model spits out a number. Churn risk, 84%. That's it. It's totally up to the analyst to dig through the variables and figure out why it's 84%.
Which is literally their job.
But look at what generative AI does. It doesn't just output the 84%. It analyzes the underlying data, contextualizes it against the company's recent actions, and says, based on these customer interactions, churn risk is high due to a recent change in our billing interface. Customers are confused by the new layout. Here is a summary of their chief complaints, and here is a drafted email to send to the product team outlining the fix.
Wow.
Right? It maps the complex correlations and immediately contextualizes it into strategic action. That synthesis, that leap from raw math to a strategic narrative, is exactly why generative AI will become the central engine of the data scientist workflow. It does the analysis and the synthesis simultaneously.
I will say that is an incredibly elegant feature of generative AI. I completely agree that its ability to synthesize a narrative is absolutely unparalleled. But listen to what you just described. It is an augmentative feature, not a replacement.
How is it not a replacement if it's doing both?
Because generative AI is fantastic at the explanation layer. It is a brilliant communicator. But the core decision, the actual mathematical derivation that the churn risk is 84% based on historical variance, is still a predictive machine learning task.
You don't think generative models will just absorb that mathematical capability entirely as they scale?
Not without changing their architecture so profoundly that they basically become predictive ML models themselves. When we talk about running quality assurance software or optimizing a global supply chain where a fraction of a percent error costs millions of dollars, the core engine generalizing those patterns must be predictive. Generative AI can wrap that prediction in a digestible narrative, sure, and it can write the SQL query to fetch the data. But the rigorous statistical engine underneath, the actual mathematics of calculating risk and variance, cannot be replaced by a text generator guessing the next logical token.
It is a fascinating boundary we are drawing here, because while you see a strict division of labor, the generative model as the communicator and the predictive model as the calculator, I look at the trajectory of the technology and I see an inevitable merging. The fact that generative AI can now write the code, query the database, and interpret the results means the data scientist is no longer spending their time building bespoke mathematical models.
They're spending time on architecture.
Right, the LLM has completely abstracted that manual layer away by offering vastly faster deployment, lower costs, and democratizing the tools so that anyone can ask complex questions of their data. Generative AI is permanently shifting the center of gravity in data science.
The center of gravity is definitely shifting, but the foundation remains exactly the same. Generative AI has undoubtedly transformed how we handle unstructured data in everyday language. It has given data analysts a phenomenally powerful new interface. But, as long as we live in a world governed by high-velocity numbers, sensor logs, financial transactions, server telemetry, predictive machine learning will remain structurally irreplaceable. You simply cannot build a reliable quantitative analysis infrastructure on top of a system designed to predict words instead of calculating math.
What really strikes me is how this debate highlights the evolution of the data scientists themselves. We seem to actually agree that the toolkit has permanently expanded,
The job is no longer just about manually tuning hyperparameters or, cleaning data pipelines for weeks on end. It is about architectural strategy.
Absolutely. Analysts and data scientists must now navigate a highly integrated, totally hybrid environment. The real skill is knowing where the boundaries lie. You use generative AI for its incredible speed, its accessibility, and its synthesizing power, but you absolutely must retain the rigorous, precision pattern recognition of traditional machine learning when you need absolute mathematical certainty at scale. It is about choosing the right architecture for the specific problem at hand.
So, we leave it to you, our listeners. Look at your own data workflows and the problems you're trying to solve right now. Where do these tools intersect in your daily tasks? Is generative AI abstracting away the need for traditional models entirely for you? Or is it simply a brilliant new lens through which we view our existing mathematical foundations? We invite you to explore the terrain yourselves, test the boundaries of these technologies, and decide whether predictive ML is on the path to being entirely replaced or if it is just being redefined.